Good morning, everyone. Hope you're okay. Here we are ready for some maths on Wednesday. So let's start with our Fab 4. Now, for today, I would like you to have a go at listing the factors of these numbers. Now, remember, factors of a number are numbers which will multiply together to give you that number. So, for example, if I wanted the factors of 12, I would think, well, 3 and 4, they times together to equal 12. So they would be factors of 12. 1 and 12 times together to give me 12. They're factors of 12. 6 and 2 multiply together to give me 12. So they're factors of 12. So all the factors of 12 would be 1, 3, 4, 6 and 12. So have a go for these ones. You've got to think carefully. Try and get all of them if you can. Pause the video, give yourself 4 minutes and then come back for the answers. Okay, so how did you get on? Now, these have got quite a few factors. 48, look at all the factors 48 has got. So we've got 1, because 1 times 48, 2, 2 times 24, 3, 3 times 16, 4, 4 times 12, and 6, because 6 times 8. So they're all the factors for 48. Here they are for 30, 1, 2, 3, 5, 6, 10, 15, and 30. 42, there they are for 42, and for 40. Now, sometimes people forget to do 1 and the number itself, but 1 times 40, that gives 40, so those are both factors of 40. Okay, well done. Right, our WALT today, we're going to be like yesterday, calculating and comparing the area and perimeter of different shapes. We need to be able to calculate the area, calculate the perimeter, and find the perimeter area of regular and compound shapes. And also we're going to have to be looking today at thinking about the facts that we know and how we can use those to help us. Maybe we might know the perimeter, or we might have a missing side, and that's going to help us then work that out to look how we could then calculate the area. So for our Discover today, Lee and Jamila have been making some handmade birthday cards. Now they're all different lengths and widths, but you can see that Lee has said we've used ribbon to decorate the edges. So all the way around the outside of the card, they've got some ribbon. Now for each card, they've used 32 centimetres of ribbon. So all the way around the edge of each card adds up to 32 centimetres. Jamila has said, your card is a square and mine is a rectangle. The length of my card is 10 centimetres. That's important for what we're going to do in a minute. Now it says here the ribbon fits around each of the cards exactly. And our first question is, what is the area of Lee's card and what is the area of Jamila's card? Now let's have a think first of all what we know. We need to find out, don't we, the length and the width of each card first before we can calculate the area of either of them, all right? Now, this is an important thing that we know already, is that the ribbon going around each card adds up to 32 centimetres. So that means then that the perimeter for each card is 32 centimetres. Now, yesterday, some of the work that I was getting back, some of you were getting a bit confused with the difference between perimeter and area. Now remember, for perimeter, that is the total if we added all the lengths together on the outside. So we'd add the width, the length, the width, the length, all together. That's the perimeter. The area is where we multiply the length by the width to get the area of the inside of the shape. So make sure that you're clear with the difference between those two. Right, back to the question. We're going to start off with then working out the area of Lee's card. Now, here's what we know about Lee's card so far. We know that Lee's card is a square and we know the perimeter is 32 centimetres. So that means all the way around the outside of that square adds up to 32. Now, how can we calculate the length of each side? Now, we need the length of each side because we've got to multiply the length and the width to find the area. Now, because it's a square, we know that the perimeter of this square is 32 centimetres. A square has 4 equal sides, so we can just do 32 divided by 4. And that then tells us that each side has a length of 8 centimetres. So can you see that we know that the perimeter then is when we say, if we put a point on and you think I'm going to do 8, add 8, add 8, add 8, or 8 times 4 in this case, because they're all the same length. and that will give us the perimeter for that shape. Now, the original question though was saying, what's the area of Lee's card? Now, remember, if we want to work out the area of a shape, we need to take one of the lengths and multiply it by one of the widths. Okay, so here we could do 8 times 8, which gives us 64. So the area for Lee's card is 64 centimetres squared. Okay, now we've managed to calculate and figure that out just from knowing the area and using our knowledge of the fact that a square has 4 identical length sides. And so we've then found out what one length and one width is, multiplied them together, and that's given us the area. Now, Jamila's card is a little bit more tricky. So her card is a rectangle. We know that the length of the card is 10 centimetres and still the perimeter is 32 centimetres. Now, there are 2 different ways that you can do this. This is how I would do it. Because first of all, we've got to think, what is the width of the rectangle? Okay, now here is the rectangle. And we know that the length is 10 centimetres. That means that the length on this side will also be 10 centimetres because they're a rectangle, so they're going to be the same. So what I would do, I would think, well, so far then, if I do 10 add 10, that gives 20 centimetres. So I know that the perimeter of the 2 red sides so far total up to 20 centimetres. Now the whole perimeter of the shape is 32 centimetres. Now if I then take away 20 from there, that's going to tell me, isn't it, what the 2 widths, the 2 blue lines you can see on here, total. So 32 take away 12 take away 20 gives me an answer of 12 centimetres. Now that means that this width here, this width and this width together add up to equal 12 centimetres. So how am I going to calculate one of those sides? Well, I've got to think, well, if there's 2 of them and they both add up to 12, I've got to half 12, haven't I? Divide it by 2. So 12 divided by 2 is 6. And so that tells me that the width of the rectangle is 6 centimetres. So do you see how we've calculated that? We've got, right, the 2 lengths add up to 20. I've taken that away from 32 to see what's left and then halved it. And that's given me then one of the widths. Now, are we finished? No, we're not, are we? Because we need to find out the area of the shape now. Now, remember, area is length times width. So this time we've got to do 6 times 10 centimetres, which equals 60 centimetres squared. So actually the area of Jamila's card is 60 centimetres squared. Okay, so a few different steps depending on the shape that we have, but we can, if we know the perimeter and we've maybe for a rectangle got one of the sides, we can find out the area of that shape. Okay, let's have a look at the second part of the Discover. Mrs. Dean now picks up another card from the table. What could be the area of the card that she chooses? What do you notice? Now, we've got to remember that all of these cards that we're looking at here, they all have the same perimeter, and they all have a perimeter of 32 centimetres. So this is going to be the key to figuring out the different areas of cards that she could possibly choose. Now, the perimeter is 32. Another way of looking at this is that if we draw here, if I draw a small rectangle, okay, now we know that the perimeter is the total of all the sides added together. Now, if it's going to total 32, if I sort of split this in half like that, really, I only need to know one width and one length in order to work out the area, don't I? Because we know that the others of the opposite side will be the same. So in this case, to make the perimeter equal 32 each time, if I make sure that my length and my width add up to equal half of 32, which is 16, then really I can figure out any other combination of lengths and widths to keep the perimeter at 32 and then look at the different possible areas of the cards. So let's look at this first one here. Now, if I think using that thinking that my length and width have got to add up to 16 centimetres, I can think, right, okay, so this time I'm going to make the length 13 centimetres. So if that's 13, it's got to add up to equal 16. This one might equal 3 centimetres. Now, what's the area going to be? That means the area is going to be 13 times 3, which is 39 centimetres squared. We can double check, can't we, that our perimeter is still correct? Because if this is 13 centimetres, this must be 13 centimetres. If that's 3, this must be 3. So if I add those all together, well, I can do 13 and 13, 26. Add 3 is 29, add another 3 is 32. So our perimeter is still 32 centimetres. Great. Let's try another one. Now this time, let's say, okay, I'm going to make my length 12 centimetres. Now, I've got to use that thinking, right, half of 32 is 16. So this has got to add up to the width to make 16. So this must be 4 centimetres. Should I check the perimeter? Well, 12 add 12 is 24. Add another 4 is 28. Add another 4 is 32. Yes, my perimeter is still 32. So for my area now, length times the width, that would be 12 times 4, which is 48 centimetres squared. Do you get the idea? So if I were to write on here that this time, this length is 11 centimetres, what do you think the width would be this time? Think about the fact that it's got to total 16, so it must be 5 centimetres. Now, how am I going to calculate the area of this rectangle? Have a think. I'm going to do 11 times by 5, so this one would have an area of 55 centimetres squared. And remembering each time, area has centimetres squared, perimeter is just centimetres. Okay, one more then. So here we go. Imagine this time I've got my width of 7 centimetres. The other way around this time. So if my width is 7 centimetres, my width and my length have to add up to what? Have to add up to 16. So what do I need to add to 7? I need to add 9 centimetres. So this time, 9 times 7 for my area gives me an area of 63 centimetres squared. So what have we done here? Well, we've managed to create cards, all of which that have the same perimeter. They all have the perimeter. If we were to add up all the outside edges of those, they would all add up to 32. But they've all got different areas. So if we were to see them on a card shop, they'd all look like different sizes because the actual area they cover is different. All right, think together. Now then, we've got here 3 different gardens, which each have a perimeter of 20 metres. So this time all the way around the outside is 20 metres. What are the missing lengths and widths? Well, maybe you should have a go at pausing the video here and seeing if you can think about what the combinations are here. All right, so hopefully you've paused and had a turn. Now, for A, let's have a look at the missing lengths and widths. Now, I know that the perimeter has to be 20 metres. So let's use the same thinking that we've just done on the previous slide. So if I half 20 metres, that means that the length plus the width would equal 10 metres, wouldn't it? So on this first one, if this one's 1 metre, this one here must be 9 metres, okay? Let's check that we're correct. 9 add 1 is 10, so this must be 9 metres and another 1 metre. 10 add 10 is 20. Great, so they are the correct lengths and widths for number A. Now for B, this is a square, so all the lengths are going to be the same. So what do I have to do in this case? Well, I just need to think, well, 20 is the perimeter all the way around. So I just have to divide that by 4 because there's 4 lengths the same. So these must all be 5 metres. Now, finally then, on rectangle C, if this length is 4 metres, okay, well, I'm thinking, well, half of 20 is 10, therefore this must be 6 metres, all right, to work out the right perimeter. Now, part B said, what's the area of each garden? So now for each one, we're just going to multiply the length times the width. So for A, 9 times 1 is 9 metres squared. For B, 5 times 5 is 25 metres squared. And for C, 4 times 6 is 24 metres squared. Okay, so what is the same about the gardens? Well, they all have the same perimeter, don't they? Because they all have a perimeter of 20 metres around the edge, but then what is different, that they have a different area. All of them have a completely different area inside, okay? So think really carefully about how to calculate and to figure out the differences between the perimeter and the area. Okay, let's have a look at this next thing together. Now it says calculate the areas and perimeters of these pairs of shapes and then compare them. So maybe you should pause the video and go and have a look, see what you think and come back. All right, so let's have a look then. I'm going to write over here so it's a bit clearer. Now let's look at shape A. First of all, let's think about the area. Okay, so the area is the length times the width. So here we've got 5 times 3, which gives us an area of 15 centimetres squared. All right, now perimeter. The perimeter for this one, well, we've got 5 times 2, which is 10, 3 times 2, which is 6. So the perimeter is 16 centimetres. Okay, now for shape B, it's a bit of an unusual one because we've got chunks come out. It's actually an irregular shape. It's a compound shape because it almost is like 2 rectangles have been stuck together. But we can still work out the area. Obviously for this one, we've got the squares to help us, but you could split them into 2 rectangles, find out their areas and add them together. But in this case, we might as well just add the numbers of squares that are inside. So for the area here for B, you can see that there's 2 by 1, 2, 3, 4, 5. So there's 10 here, 11, 12, 13. So for this one, the area, okay, the area is 13 centimetres squared. Now, let's have a look at its perimeter. So the perimeter for B, this is where you've got to make sure you add really carefully. I always put a little dot where I'm starting so I know where I've begun. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the perimeter is actually 16 centimetres. So that's funny, isn't it? Because look, it actually matches the same perimeter as A, but it has a different area. Because if you think about it, if we filled this in to make a rectangle like this, it actually would have the same dimensions as A. It would be 5 across its length and it would be 3 down its width. Now that would mean 5 times 3 would be 15 centimetres squared and the perimeter would be the same of 16. Now obviously this one here has had these chopped off, so we would expect the area to be smaller, which makes it 13 centimetres squared. However, how interesting that even though they've come out, the perimeter of those 2 shapes has stayed the same. And you will find the same for shape C. So shape C and D, so C, the area is 12 centimetres squared. The perimeter, add 4 is 8, add 3 is 11, add another 3 is 14 centimetres. Now for shape D, our area, we've got 9 squares here is 10. Now that would make sense because you can see again, it's like 2 squares have been taken out from shape C. Okay, so that would be 10 centimetres squared. The perimeter this time, let's go and have a quick look, is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And again, the perimeter stays the same as shape C. So sometimes when you've got bits chopped out, the perimeter bizarrely can stay the same, even though the area is different. All right, well done. There's been a lot to take in today because it's real problem solving in a way with this area and perimeter today. You've really got to use your known facts, both of these, to help you calculate the perimeter if you know the area and vice versa. So have a go. Remember, you can always re-watch the video if there's areas which you do get stuck with. You work on pages 123 to 125 and do make sure you send me a message if you get stuck or confused with any of it. Well done, and I'll see you tomorrow.